In Chapter 16, the discussion is on something called joint costs. This is where you have multiple products, perhaps, that you're producing, and up to a point, there is a joint process, so those costs are related to all products, and then at a point called the split-off point, the different products go into different processing, and the question becomes, how do we go about allocating the joint costs to each of the products? So I'm going to walk us through an example here. In this diagram, what we can see is we produce three products, X, Y, and Z. Up to the split-off point, we incur $580,000 in costs. At that point, we break the products down into the three different products. Product X we sell at $1,200 per ton. We have no additional work to do. Product Y we sell at $900 per ton. We have no additional work to do. And then we're going to assume for this example, and I'm going to change this for one of the calculations, we're going to assume that product X we don't sell at the split-off point. We incur an additional $200,000 in costs, and then we sell that product at $600 per ton. So that's the scenario. Now, let's look at some calculations in terms of how we go about allocating the $580,000. The $200,000 isn't an issue because it is solely dedicated to the production of product X. The only issue is, how do we take these $580,000 in joint costs and allocate them to the different products? So let's go to the next page. And all I've done here is I've put some data up here. We're producing 200 of X, 600 tons of Y, and 700 tons of Z. Now, in that drawing, it didn't look like Z could even be sold at the split-off point, but I'm going to add an assumption here and say, if we sell them at split-off, we'll sell X for $1,200, Y for $900, and at that point, if we do not do any further processing for Z, we can sell it for $300 a ton. Then after the additional costs of $200,000 are spent on Z, we can actually double our sales price because we've refined it into a different product. And then here are our joint costs. So I'm going to walk through four approaches to allocating the joint costs among the three products. The first is called the relative sales value at split-off point. And what this assumes is what we'll allocate the $580,000 in joint costs based on the proportionate sales that we could receive from each product if we sold them at that point in time. So for X, we've got 200 tons. We'd sell it at that point for $1,200, which would be a total of $240,000 in sales. Y, we have 600 tons. We would sell at $900 a ton. So that would be a total sales value of $540. And then the Z 700, again, we're assuming if we don't spend the additional $200,000 in processing, we can only sell it for $300. That would be a total of $210,000 for a grand total of $990,000. Then I'm just going to take the percentage. This isn't really net realizable value. I'm just going to take the percentage of each individual sales value times the total, and then I will multiply that percentage times the joint costs, and that will be how we allocate the $580,000. It's pretty straightforward. It's allocating based on what you think you can get for the product once you have incurred those costs. So it's kind of an ability to bear approach to allocation. The second approach is what's called the net realizable value. And it is similar, except it takes into consideration the fact that we would carry out the production of Z all the way through the final product, incurring the additional $200,000 in costs. So we'll come up with the sales value for each, which for X and Y is exactly the same because there is no additional processing for each of them. But remember, Z, if we process it further, we can sell it for $600 a ton. So the sales value actually goes up to $420,000. However, we have to take out those $200,000 in additional costs. So that means we'll have a net realizable value for X of 240 because there are no additional costs, Y of 540, again, no additional costs, and then 220 for Z, which is the increased sales value minus the 200,000, for a grand total in sales at this point of 100,000. Then we'll walk through the same calculation. I'm going to take the net realizable value for X divided by the total, the net realizable value for Y divided by the total, the net realizable value for Z divided by the total, and then I will multiply that by the joint costs, and that is how we will allocate them to each individual product. Keep in mind, the only reason we're having to allocate them to the individual product is to determine the cost basis for the product so we can figure out our price on that product and the gross and the profit that we're earning on each product. It doesn't change the bottom line, merely how we are pricing our product. Again, we're looking at an ability to bear approach. The third method I want to walk through is what's called a constant gross profit percentage. What we're going to do here is determine that what our gross profit would be once we sold everything. So the final sales value of all three products is $1,200,000. The total cost is going to be the $580,000 in joint costs plus the additional $200,000 we have to spend on Z, which means overall we're looking at a gross profit on the three products of $420,000, which as a percent of sales is 35%. So what we're going to do for this one is we'll take X, Y, and Z, the total sales, and then we'll determine what gross profit for each would yield a 35% gross profit percentage. And then, remembering that sales minus cost is gross profit, then sales minus gross profit is cost, we'll back into the cost saying, okay, if X is going to if we want X to yield a gross profit of $84,000, then they will need to be allocated total costs of $156,000. Y will need to be allocated total costs of $351,000. Z will need to be allocated total costs of $273,000, of which we already know $200,000 represents the dedicated cost to finishing Z. And so here's what we wind up with allocated joint costs. The $156,000 and $351,000 for X and Y, and then the remaining $73,000 for Z. Here's the problem with the constant gross profit method. It seems pretty straightforward. The thing is, when you're producing multiple products, it's not necessarily the case that every product will or should yield the same gross profit percentage. So in this case, we're really somewhat building a profit, a gross profit that may or may not be appropriate. And then the last method is the physical measures method, and it basically says we're going to ignore sales value, costs, all of that, and we're just going to allocate the joint costs based on the amount of tons of product. So it's a weight thing or a volume thing. We're not tying it at all to costs or work done or anything. And so what we're doing here is I've just drawn down the amount of tons of each product that we are producing, taken the percentage of each to the total, and allocating it to the joint costs. Pretty straightforward. Not a lot of direct relationship there. I would argue that probably the most widely used method is the net realizable value method. That, I think, seems to have the best connection between allocation and and a viable relationship, i.e. ability to bear.